Okay, so today we're going to do the review for the Chapter 2 test. It is going to be on Thursday. We do not have school at Mineola on Wednesday, and then of course we covered the circles and the midpoint. So I wanted to just work a few problems just to make sure you guys are ready for the test then. And in Ingalls, again, I can work more problems if you email me. If you're struggling with any of them, or I can even meet with you tomorrow sometime individually. So just let me know what I can do to help you get ready for your test. So the first page, I kind of talked to Kirsten here at Mineola, and we felt like, this part and her quiz was good. I have not seen your quiz yet, but she did great on this part. So I'm going to go ahead and skip this part. If I need to go ahead and do a little bit more, guys, I sure can. But the vertical line test to determine whether the function y is a function of a graph. Remember on this one, if I do any vertical line and it hits two different places, that means it's not a function, because our function states that every member of the domain has a unique value of the range. So remember, we had it like a parabola. Let's go ahead and just put the parabola on the other side. Obviously, if I draw any vertical line on the graph, it's only going to hit once, and that means that every one of my x values has a unique member of my y values. I wanted to go ahead and maybe go over a couple of problems. For instance, on this one, use the graph to determine the domain, and we will be writing these in interval notation. So remember, domain is going to be the which values? X values. And so I'm looking right here on the x values. So I'm going to look to see what my smallest x value is on this. So in this case, it would have to be 0. Good. And then I'm going to go all the way up I have this point. And what a big mistake we usually make is that we write then this point up here as the ending point. But remember, it's going to be just your x values. So come down here, and that means I'm going to go from 0 to then 1, 2, 3. Now, when I go ahead and indicate my, I'm going to go 0, 3, and then if it includes that point, I need to put a bracket. If it does not include this, in other words, this is going to go right up to 3 but not touch 3, so it's going to have to be a parentheses. Now my range, remember, is going to be my y values, and so now I am going to be looking at up and down. So I go the lowest value here is going to be then -1, but then I'm going to go the very highest value is going to be, here's 5, 6, 7, 8, and so I'm going to go from -1 to 8. And I'm going to also have to remember, I'm going to have to include this point but not include this, so it's going to be bracket and comma parentheses. So just remember, again, I think I saw, it's easy to jump and go from like 0 to 8 on this one because you're going up to 8, but remember, tell yourself again, x values for domain, y values only for the range. If I have an x-intercept, that's a place that's going to cross my x-axis. So here's my x-axis. And so it looks like it's going to cross right here at 1. So you can say the x-intercept, in abbreviated, equals 1. I also allow you to write the point, or you can say the point, this is going to be, then move over 1, and it's going to be 1, 0, and it's that point. And if it's along this line, I get it, because this, to me, looks so much like an interval notation. But anyway, you can write it either way. Y-intercept looks like the only place that's going to cross my y-axis is right here at -1. So that means my y-intercept is going to equal -1, which means that point is going to be 0, -1, and you can also write it at that point. Now, if I have f of 2, that means my x value is equal to 2. And so I'm saying, well, if x is equal to 2, where's the y value? So I have to come up, and I have to come up here, and it looks like it crosses right here. And so that it's going to be then the f of 2 is going to equal 4. I know that on some of our homework part, I'm going to just make an f real quick. If we had f of x is equal to, and let's say I'm going to jump up and I'm going to say x is going to have to be, let's just do 1, 2. Okay, okay? It's where the y value is actually 2. So in other words, if f of x equals 2, you're saying where is y equal to 2? So I've got to go up here, 1, 2. I've got to find out where it's going to cross, and it looks like it's going to cross between then 1 and 2. So let's go ahead and say that the x probably is about like 1.75. And again, with this graph, it's kind of hard to tell, but that's what that means, and that's the difference between those two. So remember, if this is going to be the x, x is 2, look for the value for y for f of x. Now, if we're going to determine odd, even, or neither, we substitute f of negative x into my equation. And so if f of negative x goes into the equation and it doesn't change any of the signs of my function, I know that it's going to be even. If it changes every one of them to the opposite, then it's going to be odd. If it changes only some of them, then it's going to be a neither. So in the first one, if I have f of negative x, I'm going to go 3 times negative x to the 4th power plus negative x to the 8th power plus 3. And then I'm going to simplify. Well, anytime I have a power, if I have negative x to the 4th power, that's just going to make it positive, isn't it? So this is going to change back to 3x to the 4th. I have negative x to the 8th power, so it's going to be plus 8 to the, or x to the 8th power plus 3. And notice that's exactly the same function that I started with. And so this tells me that that's going to be an even function. Remember, even was also symmetric about the y-axis. Now let's do the next one on f of x. If I have 2, oh man, I can't write a 2 today, and I have negative x to the 3rd power minus a negative x. So in this case, when I have negative x to the 3rd, that means I have an odd number of negatives. That's going to keep it negative. And so this is really going to be a minus 2x to the 3rd. And in this case, if I have a minus and a minus, I have x to the 1st. So I can go ahead and distribute. This is going to change this then to plus x. And if you notice that every one of my terms change signs, and that's a clue. You could also pull out a negative if you want, and then it has to go, not a negative 2, just a negative. So pull out a negative, and then you would end up, then a positive 2x to the 3rd minus 3rd. And notice the side is exactly the same with that negative out in front, and that's going to be a case where it's going to be an odd function. And of course, you bet you can guess the next one's going to be neither. But let's go ahead. If you go f of negative x, we'll show it. So we're going to have 2 to negative x to the 4th power. And then I'm going to go minus 3 times negative x, and then plus 1. Notice on this one I'm going to have 2x to the 4th. It's going to make it positive again. But this one is going to actually go plus 3x because I have a negative times a negative and a plus 1. And notice that my sign stayed the same for the first one, and it was opposite on the next one, and then the same again, so this one's neither. What did you notice about when, what would be another clue for odd and even? I think you noticed
if there's a, like this one had just a 1 instead of a 2.
Okay, right. So in other words, if you notice, all of the first ones on even, they were all even powers. Mm-hmm. But then the next one, they were all odd powers. Mm-hmm. On the third one, they were a mixture of the two. So that is also yet another clue that you can kind of use to determine odd and even and neither. Remember, odd functions also were reflective about the origin. So what happens is that like when you had a positive, when you have x comma y, like a point, then you would also have negative x comma negative y. Okay, so this one was a little tricky, a little bit on the test. So let's go ahead and remember domain. We know are going to be the x values. Okay, so I'm really going to look just again left and right. Okay, so I'm going to go, if I go to my furthest left, this arrow is showing that it's going to go to negative infinity. I know that my smallest value is just going to be negative infinity, but look at my right value. It's infinity also, because this arrow is showing that it's going to continue up, and that's also going to tell me that my x value is going to continue as well. So I have from negative infinity to infinity. Make sure you put parentheses on both of those. My range, though, is different. Now remember, this is up and down. So the smallest value I have coming down would be
-1.
Yep, you got it, -1. And then I'm also going to go, again, because it's going up, it's arrow up, it's going to say it's going to go to infinity. Now, in this case, it includes the value -1. So what do I need to put at -1?
A bracket.
Good. Okay, and then my x-intercepts, again, it's going to place where it crosses my x-axis. And so this case it's going to be at 2 and also looks like 1, 2, 3, 4. So my x-intercepts are going to equal 2 or 4. Remember, you can also put those as a coordinates. So you could go 2, 0 as a point or 4, 0. Y-intercepts, I'm going to look to see where it's going to cross the y-axis, and it looks like it crosses at 8. So in other words, my y-intercept is going to be then 8 or 0, 8. Now, increasing. Now remember, when you do these, increasing, decreasing, and constant, we're going to write an interval notation. You've got to remember about those x values. So increasing, so in other words, it's going to go up. So it's really going to start at this point and go up. But what would my x value be at this point?
-1.
Okay, yeah, that would be the y value. You're right. That's this point. I have 1, 2, 3, and then go down 1. So it's going to increase though with my x values. I'm going to go 3 to then infinity. And this one tricks a lot of people. Okay, and again, increasing to it really. I'm going to put a parentheses because I just can't put a bracket because right at 0 it's changing directions. Therefore, I really feel like for a brief moment it's actually constant. It's going to be 0, but I do not take off on those. So if you put a bracket there, I would accept it as well. I just need to make sure you have the 3 and the infinity. Then decreasing, I know that from this point to this point it's decreasing. So again, look at your x values. My x value right here would be
0.
good, 0, and then I know earlier it was 3. So I'm going to go decreasing from 0 to 3. And again, I'm going to go ahead and put my 2 parentheses around it. And then constant. Now here's where it's constant. So the left side would be then negative infinity until I get to what point? On the x value. 0. Good. Because it's so easy to grab the 8 and put it there. So make sure we get that. Again, number where there's a relative minimum. Minimum means that it's, in this case, it's actually the actual minimum. It's going to be down here where it stops. So the point, the number where it's a relative min. The min is talking about the y value. So I actually would accept it's a minimum value at -1, but I also would include the point 3, -1 is my minimum. Okay. Excuse me. And I'm not sure. I think this was actually supposed to be max. I'm not sure. I'm going to have you cross out. I think that was just a typo. The next one is f of -4. Now that means that x equals -4. So come over here, 1, 2, 3, 4. This is the x value for that. And then I need to find out what the value of y would equal at that. So then come up to, so it's going to equal f of -4 equals 8. And then the values were f of x. So this time the y value is 3. So they're going to say, what is the x value? So let's go up 1, 2, 3. It's right there and right there. So the y values when y is 3, okay, which is going to be right here, the x value would be 1 and also 5. Yeah, I think it's 4, but I understand. So yeah, it's kind of hard to see, but yeah, I think let's go 1 and 4. And of course, on this one, odd, even, or neither, you would say neither because it's not symmetric about the y-axis. It's not symmetric about the origin, and so you would that's kind of where you're at. Okay, I want to make sure we understand how to graph piecewise functions. So I have 2 functions. I have one, well, f of x is equal to x plus 5 when x is going to be less than 2, and I also have f of x or y equals x minus 5 when x is going to be greater than or equal to 2. And so I want to do those simultaneously. So in other words, those 2 regions. And I'm also going to look at 2. I've got I'm just going to put a whole dashed line because that's the place where it's going to change. I'm going to use one function that's going to be to the left of that line and another function to the right of that line. Now, when we do these, if you notice the y-intercept is included in my function, my region from less than 2. So if I look at y equals x plus 5, and I think about the terms of y equals mx plus b, b is equal to 5 and m is equal to 1. And so you can graph this one just like you've done, is just have to stop at 2. And so in this case, I'm going to go up 5. Here's 6, there's 5. And then I'm going to go up 1 over 1, up 1 over 1. Now, at this point, remember, it's not, when it gets to 2, it's not equal to it. So what do I put at 2? Open circle, yeah. Now, on this one, I would like you, maybe just to, because I can't really use y equals mx plus b, but let's just look at what happens when x is equal to 2. Because if I find that value, then I can apply my slope formula. So if x were equal to 2, then I would have a negative 2 minus 5, and that's going to be negative 2 minus 5 would be negative 7. So then I would go down negative 7. I'm going to go 2 comma negative 7, so it's going to be this point right here. And then my slope, is it positive or negative? Negative, so I'm going to go over 1, down 1, over 1, down 1. So it's going to be this line right there. Okay? Hey, do you need something right away, or can you wait just a few minutes? I've got a former student, so she can help us with this because she'll probably remember all of this stuff. All right, the other ones that I'm going to do is I'm going to go ahead. Remember, find the slope of the line that and indicate whether the point rises or falls. So remember, m, I'm just going to let you apply that, is equal to the y minus y over x minus x. Make sure that you put a point, you use the start point on each one. I'm going to make each one x sub 1 minus x sub 2, but I'm going to let you guys do this one. I'm going to remind you about point slope form. Now, the point slope form is, remember, y minus y sub 1 is equal to m times x minus x sub 1. And then these are the values that you're going to plug in for your numbers. So here's the numbers for x sub 1 and y sub 1. And I'm going to let you guys finish that one. Okay? And then this one, if you have x equals 4, means every value is, so it's going to be a vertical line because every value for x is equal to 4. I'm going to let you guys try that one on your own as well. I was going to jump ahead. I feel like we were pretty confident on the slope and the y-intercept, and then so you would solve this equation for that and then graph it. We are good with that. And then using the intercepts. Now remember, on intercepts you have the x-intercept. That means that y equals 0. Okay, if you're looking for your y-intercept, you're going to let x equal 0, and then you're going to have 2 coordinate points. You're going to plot those, and then you can draw your line. Wow, we went fast to those. The ones I did want to do, I want to remind you on, would be we're going to, given the equation of the line in point slope form and in slope intercept form, so you want to do both, of the line passing through this point, but it's also parallel to the line y equals negative 4x plus 3. So if I start off this, if I go y equals negative 4x plus 3, I first have to identify my slope. So my m is going to equal
3.
Yeah, remember that's the y-intercept.
Oh,
4. Yeah, 4. So it's negative 4. If 2 lines are parallel, that means the m is going to be exactly the same. So that means when I go y minus my, so it's going to be, in this case, negative 7, is going to equal a negative 4 times x minus my x value minus 9. And then I'm going to end up going y plus 7, because I have 2 negatives, is equal to a negative 4 times x plus 9. And then I want to go ahead, this one right now is in point slope form. So this is the first part. In order for me to get it in the slope intercept form, all I want to do is go ahead and distribute my 4 and then solve it for y. I'm going to let you guys finish that part, if that's okay. Now, so this is going to be A. Now, B tells me I want the line the same line, but I want it now perpendicular. So remember, our m was equal to a -4. So the slope of the line that's perpendicular to this line that has a slope of -4 has to be what? What did we do to make it perpendicular to the slope?
Reciprocal.
Yep, the reciprocal, and you also change the sign, so it's a negative reciprocal. So I'm gonna change the sign to a positive, and then I'm gonna make the reciprocal would be 1/4. So again, I'm gonna go y. I'm gonna go minus a minus, the same point. 7 is equal to now 1/4 times x minus a minus 9. And then to simplify it, I'd go y plus 7 again is equal to 1/4 times x plus 9. That is my first part. That's the point slope form. And then to get it into the slope intercept form, you would just solve for y. Are you good with that last part?
Mm-hmm.
Okay. This one is to me a little bit. These are to me a little tricky, but I want to go ahead when you're doing this for the test. My suggestion would be identify each of your points function. So I'm going to go -6, 0 is my first point. I'm going to go -4, 2 is my next point. I'm going to go -2, I'm going to count it 4. Yeah, thanks. And then I've got 0, 4. And then I've got 2, 2. Now, what we're going to end up doing is we're going to transform these points. Okay, so in this case, this is going to be, first of all, I'm going to look at my x values. When I go within my function, this is going to tell me that I'm going to either go left or right. When it's minus, it looks like it's the opposite because I have a -2 that makes me think left. But it's always the opposite, so that means I'm going to add 2 to this one. So my x value, I need to add 2. But then what happens on my y value is that I need to, since the 1/2 is on the outside, I'm going to take my y value times 1/2, and then I'm going to add 1 to it. Okay, so remember, whatever's inside the function, you need to do the opposite. Okay, so if I had 2 in here, we would actually take it times 1/2. But then, all I want to do is I want to change each of my x value or my x and y values using this manipulation. So if I go -6 plus 2, that's going to just give me -4. If I go 1/2, okay, so I'm going to go 1/2 times 0 plus 1, so that would be 1. And so my new point then is going to be 4, 4. Next one, I'm going to do the same thing. I'm going to go -4. So -4 plus 2 would be the -2. I'm going to go 2 times 1/2, so that's going to be 1 plus 1. So 1/2 would be 1 plus 1 would be then 2. See what I'm getting at?
Mm-hmm.
Okay. And then I would just continue going down on the rest of them. Can you get them after that? I think the hardest part right here is this, deciding what to do. And just remember, anything that's outside, this is going to change my y value. That's moving a translation up. And you have to multiply it times the value of y if it's on the outside. So f of x, remember, is y, so you take that, multiply it times the 1/2. All right, I'm going to go ahead and jump to the next one. These are transformations, so you need to look up this square, f equals the square x squared. And then you'll also need to know how to do the absolute value. Remember, the difference here is a u versus a v. And in this one, the transformation. So within the function, remember, this is going to tell me I'm going to move to the left 2, and then it's also going to be down 4. So if you need me to do more of those problems, I certainly can, but are you guys good? You feel like you're confident with those? Okay. The next one I wanted to do was the composite function as review. So when I do number A, which is f composite g of x. Now, f composite g of x means f of g of x. And so, even though that looks like a crazy f. All right, so what that means is within my function g of x, I'm going to replace it for what it's equal to. So g of x is equal to 5x plus 2. So I want to go f of 5x plus 2. And I know that in this case I'm going to rewrite f of x by itself was x plus 5. That means wherever I see an x, I'm going to now replace it with 5x plus 2. So that means I'm going to have 5x plus 2, then plus 5. And then I just want to simplify it. So in other words, I can add the 2 plus the 5, so I have 5x plus 7. That is f composite g of x. Now I'm going to jump down and just do c. So f composite g of negative 2. Well, I found f composite g of x is 5x plus 7. So that means that wherever I see an x now, I'm going to replace it with negative 2. So it's going to be 5 times negative 2 plus 7. And 5 times negative 2 would be negative 10. Plus 7 is going to be negative 3. Okay. Any questions on that one? Number 19. Let me go ahead. If I'm going to do the first step. You're wanting f composite g of x. And when you replace that in, so that means I'm going to go f of g of x. Okay, that means inside that is going to be 7 over x. So that means that the x down here will be replaced with 7 over x. So this is going to give me my complex fraction. So I have 7 on the top over 7 over x plus 4. And then this is where we made it, we combined these two terms. So in other words, if I have the x here, that means I'm going to multiply the 4 times x over x. That gives me the 1. So in this top part, I'm going to have 7 plus 4x all over x. And then to finish, because I have 7 over 1, I'm going to multiply my numerator of 7 over 1 times the reciprocal of my denominator, which is x over 7 plus 4x. And so I'd have 7x over 7 plus 4x. And then I would want to identify the domain. So tell me right here, what can x not equal? Can you tell me what is the problem that we need to make sure we identify? Yes, this can never be 0. So in other words, when I'm looking for my domain, I'm going to set 7 plus 4x equal to 0 and solve for x. So I have 4x is equal to a negative 7. So x is going to equal negative 7 over 4. And so my domain is going to be that I'm going to go all the way. I'm going to go from negative infinity until I hit negative 7 fourths. But then it can't equal that union with negative 7 fourths, comma, infinity. So that would be my domain. All right, the last ones we're going to do. Remember on the inverses, we switch the x and the y and we solve. Okay, so remember on this one, since this is y, when I do the inverse, then I'm going to say x equals y to the third minus 6, and then I'm going to solve the equation for y. So I'm going to move that over, I'm going to take the third, so x plus 6 is equal to y to the third. Now I'm going to take the cube root of both sides. And that would be the inverse then of my function. The next one we graph, you're going to do the same thing. So I'm going to have y equals the square root of x minus 3 is my original function, my inverse. I'm going to switch them, so x is equal to the square root of y minus 3. I'm going to square both sides, so x squared is going to equal then y minus 3, and I'm going to move my 3 to the other side. So x squared minus 3 is equal to y, but that looks like a parabola, right? We said it can't be, so the very first one, when I graph my original function of f of x, that means I'm going to move to the right 3. So I'm going to go 1, 2, 3, and it's like that half a parabola. But in this case, I remember we said that in this one, you can't... Did I do that again? Did you notice I did that? I did that on your lecture too. Mm-hmm. And I did it again. I must be, when I add 3, I need to make it a plus 3, not a minus 3. Lord. Okay, so I'm going to come up 3, and normally that would look like the parabola, but I can't have that parabola. right? Because I want to restrict my domain, because remember, it has to be symmetric about y equals x. So that means that I know that I'm going to restrict this domain, and I'm going to take off this part. And that really makes sense because I know that my original function, my domain and my range have to switch. So in this case, my domain is going to be, for my x values, has to go from 3 to infinity, and including that. And then my range on this one is going to also then, for this one, went from 0 to infinity. So 0 to infinity. When I do my inverse, these have to switch. And so that's also why you would go 1, 2, 3. You have this rest this parabola. Okay? And your domain and your range are going to switch. So it's going to go from 0 to infinity, and also from 3 to infinity. Okay? And the very last one that we're going to do, we want to remind you that we have the equation of the circle. So don't forget, when we look for the center, you're going to apply the midpoint formula. And we talked about that. The midpoint is going to be x plus x over 2, and then comma y plus y over 2. And then we find then the radius. Okay, in the graph it says the line segment goes through, so that's going to give me then my center of my circle. And then find the radius of the circle, so that means we're going to find the distance, and that's going to use the square root of x minus x expression squared plus y minus y expression squared. And that will give me my radius, and then I'm going to put it into my formula. The last one I'm going to do today, this is the formula in standard form, but I wanted to review completing the square. And notice, I was talking to Kirsten before, this problem actually is the one that we did as a class yesterday. So I'm just going to see if I can make one up. So I have x squared. I'm going to go plus y squared. I'm going to also go plus, how about 6y minus 8, or 6, usually you go x first. So 6x minus 8y. I'm going to go plus 2 is equal to 0, and it probably will not be a perfect square. But first of all, you're going to combine your x's. So I'm going to go x squared plus 6x. Remember, I'm going to leave a little room. Then I'm going to go plus y squared minus 8y, and I'm going to leave a little room. And then I'm going to move that 2 to the other side. So to complete the square, Kirsten, can you, from the room, anyone tell me what I'm going to add? Reagan's like, that was a long time ago. What did you do? Take the middle term.
Add to the outside.
Yeah, you would. No, we divide it by?
Divide
it by 2. Okay. The long-term memory didn't sit in on this one. They both had this one. So 6 divided by 2, and what did we do with it?
You put it back in, don't you?
Yeah, we do. We kind of put it right here.
Yeah.
But we have to square it first, because remember, what we want is x. Remember, this is actually going to tell me it's plus, but some number expression squared. That's completing the square. That's what our goal is. In order to find what this is, then I take 6 divided by 2, the middle term, 6 divided by 2, square it, and that's going to go right here. So 6 divided by 2 is 3. Squared is going to be 9. But Bregan was trying to tell us, yes, you have to make sure you add it to the other side, because that is most important. She was there. She just right there. So now on the next one, okay, I've got negative 8. What am I going to do with it?
Divide it by 2.
Yep, I'm going to go 8 divided by 2 is going to give me 4, right? I'm going to square it, and it's going to make me, I'm going to add then 16, but then I have to also put it plus 16. So in this case, I have the 9 plus 16, that's the 25, minus 2 is 23. I knew I wasn't going to quite get it right, but so it's okay. I can have a radical, right? So 23. So when I complete the square, remember, it's going to be whatever I have, the square root of this number, or what we took before we squared it, or the middle term divided by 2. So it's going to be x plus what? 3, yes. Because this makes sense. And that add up to 6 would be 3 and 3. Okay, the next one, I'm going to go y. What will be my sign in between? What? Factors of 16 that add up to 8. 4, but what
Oh
will
my
my
gosh.
sign in between here be? Minus, because the 8 was also minus. And then I have expression squared. Now I can tell me my center of my circle is at -3, comma 4, because you remember it looks like the opposite. My radius is going to be a fun little, yes. And it's not a whole number. That's okay, though. Square root of 23, just a little bit less than 5. Okay, that gives you an extra practice one for that. You have the one you can also practice on 24. Remember, the answer key is on your lesson plan. Okay?